Hi, in this tutorial we will work on the implementation of some thresholding exercises using SciLab. In previous tutorial we were discussing about the thresholding is basically the segmentation of images into regions with the idea that will help us to identify some objects. In SciLab, and the way that we're going to implement it is we're going to first set a threshold and then we're going to decide, okay, is the intensity value of this pixel less or than the threshold? Let's suppose that we set it to 100, then if that's the case, that's true, or a 1, and otherwise it's a 0. So we have a binary image in which basically what we want to see is a white and black image, and one of the regions in some of the exercises is be the background and the other will be an object on the foreground. Now the question is, how is that we will set that threshold? So the threshold in this case, if we're talking about a grayscale image with values between 0 and 255, then we got 256 choices. So one of the ideas is initially to get the mean value of the intensity values for the colors, and then maybe that's the threshold. Or another is using the histogram and finding local minimums in the histogram. So in the exercises that we will do, we will work on the histogram. So here is an idea what we will do. So here we had an input, and then that input is a grayscale image, and then from that we do the analysis of the histogram. That's what we have over here. We identify in this case a nice bimodal, and we set the number between those two regions. So we see that there is a lot of colors here and a lot of colors there, so there must be two areas, and then the output, it will look like this. So you see that that's the object and the background. Now we will install in SciLab another toolbox. That is the Image Processing Design Toolbox, so IPD. What I want you to do is in your SciLab to type this command that says atoms install, and then just like that open parenthesis called IPD, and once the installation is successful, you just restart, you exit SciLab and then you restart it, and then everything should be fine. So the commands that we will use here, they should work fine. Now something else that I want you to remember that we are working with images as we see that either as a function of two variables or as a matrix. And then when we have a matrix, I mean, remember that way that we can manipulate those numbers. We can transpose the matrix, like transposing is the rows becomes column, the columns becomes row, and we rotating, we do something with those numbers, either represented as a matrix, an array, or we see that as a function. Okay, so let's start with this exercise. So here again, well, here's just an analysis that we will see in the software. This is the histogram of the image. So this is what we have with the command image show of one of the pictures, and then here is how we're going to actually see the histogram there. So for my experiments, I will use 4 different images. So what you need to do is have ready 4 type of images to study the histogram of those images. So in my case, I use the basic images. I use 3 basic images from the default images that comes from a Windows machine, and I got one that is like the one from the exercises here, because this has a nice bimodal histogram. So here is the commands that you know. For example, my first image, I'm calling that P. I have the commands there in SciLab. So in my case, I'm opening that image, and then I'm doing the image show, and this is what I see. This is my second image. That's the way that I open, so you know that, and then I'm checking that everything is fine in SciLab. I do the image show P2. So far I got P, P2, and then my P3 is this. So these 3 images are in Windows. Those are the ones that are, I think, in the folder pictures, sample pictures, I think, and then this is my P3, and this is my P4. Okay, so now I'm inspecting the images just to get an idea the size of the images. I noticed that the first 3 images, as you can see here, they are about the same size, and these are RGB images or color images. Even the fourth one, because I see the have the 3 there. So for example, the first one is 76A by 1024, and then size 3. So that means it's an RGB, so it's a red, green, and blue. And then so what we will do next is we're gonna get the grayscale equivalent of those. So these 3 should disappear when we got the grayscale. So this is what we have. So these are now this is the way that we do the transformation. So for example, now I got another variable p underscore gray, and what I'm doing is the RGB image to gray. That's for P. Do the same for P2, P3, P4, and then I look at the new images, and you compare. The difference is now that they are grayscale, and if I will do the size, it should be the same size, but it shouldn't have that 3 there, because now it should be a 2D. Okay, so how is that we're gonna get the histograms? Remember that you were supposed to do the installation. So for the histograms, you have to use those commands that are listed here, and then we're gonna display those in figures. And once you do the implementation, so these are the histograms of the first 2 images, which is my P and my P1. I'm sorry, P and P2. I don't have a P1. The P1 I didn't actually put the 1 there. So you can see the histogram. You see there's some maxima. So we see that there is a lot of colors for, I think this is the koala here, and then there is a minimum here. There are several local minimums. So from there we try to see if we can find an initial threshold to divide, but what we will do is we want to work with some numbers, and I want you to do the same to see you can find a nice partition in a binary image with the objects that are listed in the image. So this is the histogram of the other ones. Again, the histogram here are numbers at the bottom from 0 to 255, which is all the intensity colors that we have for the grayscale, right? And these numbers here is the quantity or the frequency, or how frequent we have those colors. So you hear, like for example, here I don't see. Let me see if I can see it over there. I think it's numbers between 100 and 155. Here is the ones that are very frequent. So maybe we can start with a value that is 150, 100, that are some local minimums here. And then here I see that there is a minimum here in 100. You see here there is a peak in about 200 for the other one. And then let's see, this is the histogram. I guess this is for the flower. So you see, I think there is a lot of green, so maybe this has to be something with the image, and this may be something else with the background too. And the last one is the one that has this nice bimodal distribution. So we can set a threshold in this area. Okay, so then now what we can do is start working with the thresholding. Like for example, here I'm comparing the invert. Some people like to do the invert, some people don't do that. Like for example, I usually do the second command. I'm looking into the P gray, and the 130 is my threshold. So you see P gray, so we got all the numbers there, and then here I got the condition P gray greater than 130. So those will set to true or 1, and the others are zeros. And then I want to display that, and then what I see is the image here on the right, I think. This is what I see. I see this object when I didn't do the invert. So the difference with the first command, you see I'm creating a matrix with all ones, because remember this is binary, so all ones, that's the size of the image, 768 by 1024. Then I multiply by 255, which is the max numbers in this case, minus P gray 130. Now in the experiments, I mean, you can just work with the image. I mean, this type of experiments are really easy with the thresholding. I mean, you just work with the set of numbers there and the image show, and you start changing the threshold, and then you see the type of results that we can have there. So here I have another way of doing the invert of the for my koala. So here I'm just doing this, and then I'm checking the histogram of the invert to compare it, because the one that we have there, it wasn't the invert. So I think this is the histogram of that which you see still looks kind of the same. It's just that changes. I mean, this is interesting to see how it maintains kind of the same distribution. And then you see there the threshold that I'm using there, and I'm using another command for the threshold that is segment by threshold. In the inverted image, that is 160. So this is from the new toolbox that we installed. But look at that, in the previous one I didn't use that. So there are there are some functions we don't really need to use because we can implement our own. We can also use some of the functions that are there. So this is another result of that experiment. So now here is another result if I change the threshold to 90. So I think this is something easy that you can start working. And again, by looking and finding the right threshold is kind of the initial step of segmenting, and you saw other ideas of extending this concept to further segment or divide into other type of regions, like for example maybe this will be in a specific area of the object, but I think this looks nice. So this is another experiment with the last image. I don't think I implemented the others, but I mean you can work in the others by doing the same command. So here for example I'm not doing the invert. Here we're doing the invert. Basically you see is the difference, like here the background is white and the object is black, and then here is the other way around, the background is black and the object is white. So it just depends sometimes on the preference. And maybe from here you can work on some other testings for this type of algorithm.